Ladies and gentlemen, today we stand at a pivotal moment in history. A groundbreaking development in transportation has just taken the world by storm, signaling a major shift in global technology and innovation. This latest advancement is not just an ordinary leap forward. It is a strategic move that has sent shockwaves across industries and governments alike. This new generation transport system represents a breakthrough that combines cutting-edge engineering, state-of-the-art design, and an unmatched level of efficiency. It pushes the boundaries of what was once thought possible, redefining the standards of high-speed transportation. The speed, capacity, and sustainability of this system are unparalleled, making it one of the most impressive technological feats of our time. But beyond its sheer innovation, this development carries deeper implications. The transportation industry is more than just moving people and goods. It is a fundamental pillar of economic power, military strategy, and global influence. With this new system, a major player has solidified its position at the forefront of technological dominance. For years, the U.S. has been a leader in advanced transport technologies. However, this new leap forward challenges that dominance. With a design that surpasses many existing models, it raises serious questions about the balance of technological superiority on the world stage. The efficiency, speed, and potential military applications of this system have caught the attention of experts and policymakers worldwide. From an economic perspective, this development could reshape global trade, supply chains, and industrial capabilities. Nations that adapt to this new system quickly will gain a competitive edge, while others risk falling behind. The stakes are high, and the response from the U.S. and other global powers will be crucial in determining the next chapter of technological competition. But what does this mean for the future of transportation as a whole? The innovation we are witnessing today is just the beginning. With advancements in artificial intelligence, automation, and green energy, the next decade could see even more revolutionary changes. Countries that lead in these sectors will set the course for the rest of the world. As reactions continue to unfold, one thing is certain: this moment marks a turning point in history. The world is watching closely, and the race for the next generation of transportation is far from over. The only question that remains is, how will the rest of the world respond? Ladies and gentlemen, today we are witnessing a moment that will be remembered in history as a major turning point in the world of transportation and technological advancement. A significant new breakthrough has just been unveiled, one that has not only stunned industry experts, but has also sent shockwaves through the global geopolitical landscape. This is not just another incremental improvement in transport technology. It is a revolutionary leap forward that could reshape the balance of power, redefine economic strategies, and challenge long-standing technological leadership. For decades, nations have competed to develop the fastest, most efficient, and most advanced transportation systems, each striving to outpace the other in a race driven by economic ambition, military strategy, and technological supremacy. The ability to move people and goods faster and more efficiently has always been a key driver of global influence. From the early days of steam engines to the rise of high-speed rail, from aviation breakthroughs to the latest in hyperloop concepts, transportation technology has never just been about convenience. It has been about power, progress, and control. What makes this latest development particularly astonishing is the sheer scale of innovation involved. This is not merely a minor upgrade or an experimental concept. It is a fully realized, next-generation transport system that demonstrates a clear vision for the future. While much of the world has been focusing on improving existing infrastructures, this latest achievement represents a bold step into new territory, one that many believed would take years, if not decades, to reach. The global reaction to this news has been swift and intense. Industry analysts, government officials, and even military strategists are closely evaluating the implications. In a world where technological dominance often translates to economic and geopolitical advantage, such a groundbreaking achievement cannot be ignored. The questions being asked are urgent. How does this change the future of global transport? What does it mean for industries that rely on high-speed logistics? And perhaps most importantly, how will other global powers respond to this shift in momentum? Beyond its technological brilliance, This moment represents something even greater, a statement of intent. It signals that the race for transportation supremacy is far from over and that new players are ready to challenge the established order. It raises the stakes for nations that have long held dominance in this sector and forces them to rethink their strategies moving forward. We are standing at the edge of a new era, where transportation is not just about moving from one place to another, it is about who will lead the world into the future. The unveiling of this new system is not just an engineering marvel, it is a wake-up call to the world. It forces us to rethink what we know about transportation, innovation, and the shifting balance of global influence. And as we dive deeper into the specifics of this technology, its capabilities, and its impact, one thing is clear. This is a game changer. Innovation has always been the driving force behind human progress, and transportation is one of the most critical areas where groundbreaking advancements shape the future of economies, societies, and global power structures. This latest transport system is not just another technological improvement. It represents a seismic shift in engineering, efficiency, and capability. It stands as a testament to the rapid advancements being made in science and technology, proving that the limits of transportation are still being pushed beyond what was once thought possible. What makes this breakthrough so significant is the combination of multiple cutting-edge technologies working together in harmony. From advanced propulsion systems to next-generation materials and AI-driven control mechanisms, every aspect of this transport system has been meticulously designed for maximum performance. Speed, efficiency, sustainability, and safety have all been elevated to levels never seen before, setting a new benchmark for the global industry. One of the most remarkable features of this transport innovation is its sheer speed. While other high-speed transport systems, including bullet trains and Hyperloop prototypes, have made impressive progress in recent years, this new model takes velocity to an entirely different level. It is designed to drastically reduce travel times between major cities, potentially transforming global logistics, business operations, and even personal mobility. The impact of such an advancement cannot be overstated. What once took hours could now take minutes, and what was once an expensive logistical challenge could soon become routine. Beyond speed, efficiency is another key area where this new system sets itself apart. Traditional transport networks often struggle with energy consumption, high operating costs, and environmental concerns. However, this breakthrough incorporates innovative energy-efficient technologies, potentially reducing reliance on fossil fuels and minimizing carbon emissions. By utilizing a blend of advanced power sources, regenerative braking systems, and cutting-edge aerodynamics, it achieves unprecedented levels of sustainability without compromising performance. Another major aspect of this transport system is its intelligent automation. Artificial intelligence and machine learning play a crucial role in optimizing operations, enhancing safety, and ensuring smooth functionality. From predictive maintenance that prevents technical failures before they happen to real-time adjustments that enhance passenger comfort, AI-driven systems are embedded throughout the infrastructure. This level of automation not only increases efficiency, but also drastically reduces the risk of human error, making transportation safer and more reliable than ever before. Material science is also at the heart of this innovation. Lightweight, ultra-durable materials have been used to enhance structural integrity while keeping energy consumption low. The combination of aerospace-grade composites and next-generation alloys allows for a balance between strength and agility, enabling the transport system to perform at optimal levels even under extreme conditions. The development of these materials represents years of scientific research and engineering breakthroughs, further demonstrating the commitment to revolutionizing transportation on a fundamental level. Perhaps one of the most fascinating aspects of this system is its adaptability. Unlike traditional transportation networks that are often rigid and difficult to expand, this model has been designed with scalability in mind. It can be integrated seamlessly into existing infrastructures or deployed as a standalone network, making it a viable solution for various geographic and economic conditions. This flexibility ensures that the technology is not limited to a single region or nation. It has the potential to reshape global transportation as we know it. Furthermore, this transport breakthrough is not just about moving people faster. It also has major implications for cargo transport and supply chain logistics. With e-commerce, international trade, and global supply chains demanding faster and more reliable transportation methods, this system offers a revolutionary solution. Companies and industries that rely on rapid deliveries and time-sensitive logistics could benefit immensely, altering the way businesses operate on a global scale. In the grander scheme of things, this innovation serves as a bold statement, a demonstration of technological capability, ambition, and future vision. It challenges the existing norms of transportation, pushing competitors and global powers to accelerate their own advancements. While many nations have been investing heavily in transportation research, this particular development marks a decisive moment that sets a new precedent for the industry. It is not just a step forward, it is a leap into the future, redefining what we thought was possible in the world of high-speed transportation. The unveiling of this next-generation transport system is not just a technological milestone, it carries profound strategic implications that could alter the global balance of power. In today's world, transportation is more than just a means of moving people and goods. It is a critical element of economic strength, military capability, and geopolitical influence. Any nation that dominates transportation technology holds a significant advantage in multiple arenas, and this latest breakthrough is a clear statement that a new leader is emerging in this space. At the heart of this shift is the recognition that transportation is a key pillar of global dominance. The ability to move resources, deploy forces, and maintain supply chains with unparalleled speed and efficiency is a game-changer in both economic and military terms. Nations that control the most advanced transportation networks gain an edge in global trade, logistics, and strategic mobility. This new system, with its unprecedented speed and efficiency, raises urgent questions about how it will be utilized, not just for economic development, but also for strategic advantage on the world stage. For decades, the United States has been at the forefront of transportation technology, leading the way in aviation, high-speed rail, and military logistics. However, this latest development challenges that long-standing dominance. It signals a shift in technological leadership, forcing the U.S. and other global powers to reassess their own transportation infrastructure and innovation strategies. If this new system is rapidly deployed and widely adopted, it could disrupt existing global trade routes and create new centers of economic power. One of the most immediate concerns is how this breakthrough will impact global supply chains. Modern economies depend on fast and reliable transportation networks to move goods across continents. Any disruption or shift in the balance of these networks can have ripple effects across industries, from manufacturing and retail to energy and defense. If this transport system enables faster, cheaper, and more reliable shipping routes, it could attract businesses and investors away from traditional hubs, reshaping global commerce in unforeseen ways. Another crucial implication lies in the realm of military logistics. The speed and adaptability of this transport system could provide strategic advantages in mobilizing troops, deploying equipment, and responding to crises. In the past, military dominance often relied on naval fleets, air superiority, and logistical efficiency. But in an era where rapid deployment can mean the difference between success and failure, an advanced transport system could serve as a critical force multiplier. The ability to move personnel and supplies at record speeds could redefine military strategies, giving an edge to the nation that masters this technology first. Beyond military and economic concerns, there is also the question of influence. Technological advancements are not just about functionality, they are symbols of national power and progress. A country that pioneers a groundbreaking transportation system is not only advancing its own infrastructure but also positioning itself as a global leader in innovation. Other nations may seek to adopt or adapt this technology, leading to new partnerships, alliances, and economic dependencies. The influence that comes with exporting such a transformative system could extend far beyond the realm of transportation, impacting diplomatic relations, trade agreements, and international cooperation. Furthermore, the reaction from other global powers will be telling. The United States, Europe, and other technologically advanced nations will now have to determine their response to this breakthrough. Will they accelerate their own transportation projects to maintain a competitive edge? Will they form new alliances to counterbalance this shift? Or will they attempt to integrate elements of this technology into their own infrastructures? The choices made in the coming years will shape the geopolitical landscape for decades to come. Equally important is the impact on emerging economies. Many developing nations struggle with outdated infrastructure and inefficient transportation networks, limiting their ability to compete in global markets. If this new transport system becomes accessible on an international scale, it could provide a much-needed boost to regions seeking modernization. However, it could also create dependencies, with countries aligning themselves more closely with a nation that controls this technology. The long-term economic and political consequences of such alignment could be profound, influencing trade policies, investment flows, and even regional stability. As history has shown, major transportation advancements have always had far-reaching effects beyond their intended use. The rise of the steam engine revolutionized industrial economies. The invention of the airplane reshaped warfare and global travel. The construction of modern highways and high-speed rail networks has transformed urban development and commerce. This latest breakthrough is no different. It is not just about moving faster. It is about redefining the world order, shifting economic power, and challenging the traditional leaders in technology and infrastructure. The strategic implications of this transport system are vast, touching every corner of the global landscape. Governments, industries, and military strategists must now grapple with the reality that the world is entering a new era of high-speed mobility, one where old assumptions about transportation and power dynamics no longer hold. The question is no longer whether this breakthrough will have an impact, but rather how quickly the world will adapt to its consequences. For decades, the United States has been a global leader in transportation innovation, pioneering groundbreaking advancements in aviation, rail, automotive, and even space travel. From the development of the first transcontinental railroads to the invention of the airplane, the U.S. has consistently pushed the boundaries of what is possible in transportation. It has led the world in commercial aviation with Boeing, set the standard for modern highway systems, and even ventured into futuristic concepts such as the Hyperloop and autonomous vehicles. However, this latest breakthrough in transport technology presents a direct challenge to American dominance in this sector. The U.S. has long prided itself on having one of the most advanced and efficient transportation networks. Its highways, airports, and freight rail systems have facilitated economic growth and ensured strategic mobility for both commerce and defense. Yet, in recent years, the pace of transportation innovation in the U.S. has slowed compared to other global players. While America remains a leader in automotive and aerospace technology, its public transportation infrastructure has lagged behind. Many of its major cities still rely on aging subway systems, and high-speed rail projects have faced significant political and financial hurdles. This latest transport breakthrough highlights a stark contrast between American transportation priorities and those of other nations investing aggressively in next-generation infrastructure. While the U.S. has focused heavily on maintaining existing systems and exploring experimental technologies like autonomous vehicles, this new transport model is a fully realized, next-generation system ready for implementation. It demonstrates not only a technical leap but also a commitment to long-term investment in transformative infrastructure. One of the most glaring differences is in high-speed rail and public transportation development. The U.S. has struggled for years to establish a viable high-speed rail network, with projects such as California's bullet train facing delays, cost overruns, and political resistance. Meanwhile, other nations have successfully built extensive high-speed rail systems that connect major cities with unprecedented efficiency. This latest breakthrough further widens the gap, showcasing a transport model that surpasses anything currently in operation within the United States. Speed and efficiency are critical factors where this new system appears to outpace American alternatives. While the U.S. has made strides in developing Hyperloop prototypes and next-generation aircraft, these projects are still in their early stages, with no large-scale implementation in sight. In contrast, this newly unveiled transport system is not just a concept, it is a functional, deployable solution that could soon become the global standard. Its ability to drastically reduce travel times, streamline logistics, and operate with high energy efficiency places it in direct competition with existing American transport technologies. Another area where this breakthrough challenges U.S. dominance is in energy efficiency and sustainability. While the U.S. has invested heavily in electric vehicles, alternative fuels, and emission reduction technologies, this new transport system appears to integrate multiple advanced energy solutions, reducing both environmental impact and operational costs. The U.S. transportation sector remains heavily reliant on fossil fuels, particularly in aviation and freight transport. This new system's potential to operate with minimal emissions places additional pressure on American industries to accelerate their shift toward cleaner, more sustainable transportation methods. Beyond the technological aspects, this development also underscores the differences in infrastructure investment strategies between the U.S. and other global players. While the U.S. government has historically relied on a mix of public and private investment for infrastructure projects, other nations have adopted a more centralized approach, prioritizing large-scale national transportation projects as a means of economic expansion and global influence. This latest transport system is a direct reflection of such strategic planning, demonstrating what is possible when a nation commits to long-term technological and infrastructural growth. Additionally, the integration of artificial intelligence and automation in this new transport system raises further challenges for American innovation. The U.S. has been at the forefront of AI development, particularly in autonomous driving and aviation technology. However, this new system appears to take automation to a new level, incorporating real-time optimization, predictive maintenance, and fully automated operations. If successfully implemented, it could serve as a model for future transportation networks worldwide, forcing American engineers and policymakers to rethink their own strategies for integrating AI into national infrastructure. From a geopolitical perspective, this breakthrough also raises concerns about America's competitive edge in global technology exports. The U.S. has long been a major supplier of transportation technology, including aircraft, automobiles, and railway systems. If this new system gains international traction, it could shift the balance of economic influence, reducing demand for American-made transportation solutions. Countries looking to modernize their infrastructure may now consider alternative options, potentially diminishing U.S. influence in the global transportation market. Perhaps the most significant challenge posed by this new transport breakthrough is the message it sends about the future of global innovation. The U.S. has always been seen as the birthplace of world-changing technologies, from the Wright brothers' first flight to the Apollo moon landing, from the automobile industry revolution to Silicon Valley's tech boom. However, this development signals that the next era of transportation innovation may no longer be led by the United States. It forces the question, is America prepared to compete in this new age of high-speed, AI-driven, energy-efficient transport, or will it fall behind as other nations take the lead? The unveiling of this next-generation transport system is not just a technological achievement. It is an economic game-changer that has the potential to reshape global markets, disrupt traditional trade routes, and redefine the competitive landscape for industries worldwide. The economic consequences of such a breakthrough extend far beyond transportation alone, influencing supply chains, manufacturing, international trade policies, and even real estate and urban development. One of the most immediate and significant economic impacts of this transport revolution is its effect on global trade. Faster, more efficient transport systems directly translate into reduced shipping times, lower transportation costs, and increased reliability for businesses that depend on rapid logistics. In today's world, where just-in-time manufacturing and e-commerce have become the backbone of global commerce, the ability to move goods at unprecedented speeds provides an enormous competitive advantage. Companies that can receive raw materials and deliver finished products faster than their competitors will dominate markets, forcing businesses to rethink their logistics strategies. For industries that rely heavily on global supply chains, such as electronics, pharmaceuticals, and automotive manufacturing, this advancement could be transformative. Current shipping methods, whether by air, sea, or rail, have inherent limitations in terms of cost, efficiency, and environmental impact. If this new transport system can provide a faster and more sustainable alternative, It could disrupt the long-established dominance of air freight and cargo shipping, potentially shifting trade routes and making certain logistical hubs obsolete. The economic ripple effects extend even further, reaching the energy sector, infrastructure development, and international investments. Traditional transportation methods, particularly aviation and shipping, are major consumers of fossil fuels. If this new transport model incorporates advanced energy-efficient technologies, it could reduce global demand for oil and fuel, impacting energy markets worldwide. Countries that rely on oil exports may see decreased demand, while those investing in next-generation transportation technology could see a surge in economic growth. This shift could accelerate the transition toward cleaner energy sources and redefine the financial priorities of nations that depend on transportation-related fuel consumption. Another major economic consequence is the potential for job creation or disruption across multiple industries. On one hand, the development, construction, and maintenance of this transport system will require a highly skilled workforce, leading to job growth in engineering, manufacturing, and technology sectors. Investments in new infrastructure will also stimulate employment in construction, research, and urban planning. However, the automation and efficiency of this system may also lead to job displacement in traditional transport sectors. Industries reliant on trucking, commercial airlines, and shipping may face workforce reductions as businesses shift toward more efficient transport solutions. This raises critical questions about workforce adaptation and the need for retraining programs to prepare employees for emerging industries. The economic implications also extend to urban development and real estate markets. Historically, advancements in transportation have dictated the expansion of cities and industries. The invention of the automobile led to suburban sprawl. The rise of the railroad created new industrial hubs, and the development of aviation transformed global tourism. Similarly, this new transport breakthrough could redefine how and where people live and work. If travel times between major economic centers are drastically reduced, it could make distant locations more accessible, driving new investments into previously underdeveloped regions. Cities may need to rethink their infrastructure, adapt zoning laws, and accommodate the influx of businesses and residents drawn by high-speed transport connectivity. For businesses, the ability to rapidly connect distant markets means new opportunities for expansion and investment. Companies that once faced logistical challenges in reaching certain regions may now find those markets more accessible. This could lead to increased international business partnerships, cross-border investments, and a restructuring of global economic alliances. Nations that integrate this transport system early may become economic powerhouses, attracting foreign investment and strengthening their positions in global trade negotiations. The financial markets will also feel the impact. Investors and corporations closely monitor technological disruptions, and this breakthrough will likely shift investment strategies. Traditional transportation companies may see stock volatility as analysts assess the long-term viability of their business models. Meanwhile, companies involved in next-generation transport technology, infrastructure development, and AI-driven logistics may experience a surge in investor interest. Governments and private investors will have to make strategic decisions about where to allocate resources, balancing between maintaining existing transport networks and investing in new infrastructure. Moreover, the economic competition between nations will intensify. Countries that fail to keep up with this rapid transportation evolution may find themselves at a disadvantage in global trade. The ability to move goods and people faster will create economic imbalances, favoring those who embrace the new system while leaving behind those who struggle with outdated infrastructure. This could lead to shifts in economic power, where emerging economies that adopt the technology early gain leverage over traditionally dominant economies. Beyond individual businesses and national economies, this breakthrough could also redefine global trade policies. Governments may need to negotiate new trade agreements to accommodate faster logistics capabilities. Customs regulations, import-export policies, and tariffs may be revised to align with a world where high-speed transport reduces the delays and costs traditionally associated with cross-border trade. Policymakers will need to adapt quickly, ensuring that their nations are positioned to benefit from this new era of transportation rather than being left behind. Ultimately, the economic consequences of this transport breakthrough will be felt across every sector and every corner of the world. It is not just a technological innovation, it is an economic revolution that will shape the future of global commerce, investment, employment, and trade relations. The speed at which nations and industries adapt will determine their economic success in the years to come. The development of this next-generation transport system does not only have economic and commercial ramifications, it also raises profound national security concerns. In an era where military strategy, logistics, and rapid deployment capabilities are key to maintaining global influence, the ability to move personnel, equipment, and supplies faster than ever before represents both an opportunity and a challenge. For the United States and other global powers, this breakthrough forces a reassessment of existing defense strategies, military logistics, and technological preparedness in the face of evolving threats. One of the most pressing concerns is the impact on strategic mobility and force projection. The ability to quickly transport troops and military assets across vast distances has historically been a defining factor in military superiority. The U.S. military, for example, has long relied on its extensive network of air bases, naval fleets, and transport aircraft to rapidly deploy forces around the world. However, if another nation possesses a transport system that significantly outpaces existing military logistics, it could gain a substantial strategic advantage. Faster and more efficient transportation means that reinforcements can be deployed rapidly, supply lines can be maintained more effectively, and response times to crises can be dramatically reduced. The implications extend to military logistics and supply chain management. In any conflict scenario, the ability to sustain operations depends on the timely movement of weapons, ammunition, fuel, medical supplies, and personnel. A transport system that surpasses traditional military cargo planes and naval transport could revolutionize battlefield logistics, enabling forces to be resupplied in record time. This capability would not only increase operational efficiency, but could also tilt the balance in prolonged conflicts where logistics often determine the outcome. Another significant concern is defensive preparedness and vulnerability. If a nation can rapidly deploy forces using an advanced transport system, it could overwhelm an adversary before they have time to react. Traditional defensive strategies that rely on early warning systems and gradual military buildup could become less effective in a world where adversaries can mobilize at unprecedented speeds. This raises questions about the need for enhanced intelligence, surveillance, and reconnaissance (ISR) capabilities to detect and respond to potential threats before they materialize. Additionally, the potential militarization of this transport technology is a critical issue. While the system may have been developed for commercial or civilian applications, history has shown that groundbreaking technologies often find military applications. From the jet engine to GPS technology, innovations originally designed for civilian use have been repurposed for defense and warfare. If this transport system can be adapted for military use, it could change the way wars are fought. High-speed, long-distance transport could be used for rapid troop insertions, extraction of key personnel, or even unmanned logistics operations in contested areas. The implications extend beyond traditional military logistics to cybersecurity and information warfare. As transportation systems become more advanced, they also become more dependent on digital networks, artificial intelligence, and automated control systems. This creates potential vulnerabilities that could be exploited by cyber warfare. If an adversary were able to hack into or disrupt the control systems of this transport network, it could lead to widespread logistical failures, causing chaos in military and civilian operations alike. Ensuring the cybersecurity of such a critical infrastructure will be paramount in maintaining national security. Another key concern is the potential for geopolitical power shifts and strategic alliances. If one nation is able to provide high-speed transport capabilities to its allies, it could strengthen military coalitions and reshape international defense partnerships. Nations with access to this technology could conduct joint military exercises more efficiently, coordinate rapid response efforts, and enhance their deterrent strategies. Conversely, countries that do not have access to this transport system could find themselves at a strategic disadvantage, potentially leading to increased tensions and a new arms race centered around transportation superiority. Moreover, the role of intelligence and reconnaissance in countering this technology will become even more crucial. In military strategy, the ability to predict and track enemy movements is a fundamental advantage. If a nation possesses a transport system capable of moving troops and assets at unprecedented speeds, it could potentially outmaneuver conventional surveillance and reconnaissance systems. This could lead to a reevaluation of satellite intelligence, drone surveillance, and advanced radar systems to ensure that rapid deployments do not go undetected. Furthermore, the potential for covert operations and special forces missions using this technology cannot be ignored. Rapid transport could enable special operations units to infiltrate and exfiltrate from high-risk areas in record time, making covert missions more feasible and reducing the risk of detection. Whether for counterterrorism, hostage rescues, or strategic strikes, the ability to deploy elite forces instantaneously could revolutionize the way special operations are conducted. At the broader strategic level, this development also influences arms control and international security agreements. If this transport system is seen as a game-changer in military logistics and force projection, there may be calls for new international treaties or regulations governing its use. Just as missile technology, nuclear weapons, and drone warfare have led to diplomatic negotiations and arms control agreements, the introduction of a transport system with military applications could spark similar discussions about its role in global security. Ultimately, the introduction of this next-generation transport technology represents a paradigm shift in national security and military strategy. It challenges traditional defense doctrines, forces nations to rethink their rapid deployment capabilities, and raises critical questions about cybersecurity, intelligence, and strategic mobility. Governments and military leaders will need to respond swiftly, ensuring that they are not caught off guard by the implications of this breakthrough. The future of warfare, defense logistics, and global power dynamics may very well be shaped by how nations adapt to this new reality. The introduction of this next-generation transport system is not merely a technological breakthrough, it is a geopolitical event that has the potential to reshape global power dynamics, shift strategic alliances, and redefine diplomatic relations between nations. In an era where technology plays a crucial role in political influence, the ability to control and deploy revolutionary transportation infrastructure carries immense diplomatic weight. The political consequences of this development will ripple across continents, affecting trade agreements, military partnerships, and the balance of global leadership. At the heart of this shift is the growing perception that the center of technological innovation and infrastructure dominance is moving away from traditional Western powers. For decades, the United States and its allies have been seen as the leaders in technological advancements, particularly in the transportation and aerospace industries. The U.S. has set global standards in aviation with Boeing, spearheaded space exploration through NASA, and developed the world's most extensive highway and freight rail networks. However, this latest transport breakthrough challenges that perception and signals that other nations are now at the forefront of engineering and infrastructure development. This technological leap could embolden nations that have long sought to reduce their reliance on Western technology and infrastructure. Many countries, particularly in Asia, Africa, and Latin America, have historically depended on Western-built transportation networks, including roads, railways, and aviation technology. If this new transport system is rapidly adopted and made available through international partnerships, it could shift economic alliances, allowing nations to bypass traditional Western-dominated supply chains and logistical networks. This shift in economic dependencies could lead to a realignment of global trade agreements and strategic alliances. The diplomatic consequences of this breakthrough will likely manifest in new geopolitical blocs forming around access to this technology. Nations that are granted early access to this transport system may strengthen their political and economic ties with the country behind its development, leading to a restructuring of global alliances. Countries that integrate the technology into their infrastructure will not only gain economic benefits, but may also align themselves politically with its developers, potentially altering long-standing diplomatic relationships. The United States, in particular, faces a significant challenge in maintaining its global influence. As other nations gain access to superior transport capabilities, American diplomatic leverage in trade, military strategy, and global governance could weaken. The U.S. has historically used its technological leadership as a tool of diplomacy, offering access to cutting-edge innovations in exchange for economic and military partnerships. If an alternative transport system becomes the gold standard, nations may see less incentive to cooperate with the U.S., instead forging closer ties with the new leader in transport technology. Additionally, the introduction of this new transport system could intensify existing geopolitical rivalries. Competition for technological supremacy has always been a source of political tension, from the Cold War space race to modern battles over semiconductor production and artificial intelligence. This transport breakthrough may become another flashpoint in the ongoing contest for global dominance. The U.S. and its allies may respond by accelerating their own transportation research and infrastructure investments to counterbalance the influence of this new technology. This could lead to a new kind of arms race, not in weapons but in transportation capabilities, with nations vying to develop the fastest, most efficient systems to maintain their strategic advantages. One of the most profound political implications is the potential for infrastructure diplomacy. The country behind this transport system could use it as a diplomatic tool, offering funding, construction assistance, and technological expertise to nations willing to adopt it. This could mirror past infrastructure initiatives, where nations have used high-speed rail, telecommunications, and port development projects to expand their influence. Countries that sign agreements to integrate this transport system may become economically and politically tied to its creators, leading to long-term shifts in diplomatic relations. Furthermore, this development could challenge Western-led global institutions and regulatory bodies. International organizations such as the International Civil Aviation Organization, ICAO, the World Trade Organization, WTO, and various global transport regulatory bodies have long been dominated by Western nations, setting the standards for aviation, shipping, and logistics. If this new transport system becomes widely adopted, it may necessitate the creation of new regulatory frameworks, potentially reducing Western influence in global policymaking. The developers of this system could push for their own standards to be recognized internationally, shifting the balance of power in global governance. Another diplomatic challenge will arise in technology access and restrictions. The U.S. and its allies may impose restrictions on the adoption of this transport system, citing national security and economic concerns. Similar to how advanced semiconductor technology and 5G networks have been the subject of export controls and trade restrictions, this transport breakthrough could face similar barriers. The U.S. government may attempt to block or limit its integration into allied nations' infrastructures, arguing that it poses risks to national security, economic independence, or cyber vulnerabilities. This could lead to increased diplomatic tensions, particularly in regions where countries must choose between adopting this new technology or maintaining their strategic partnerships with the U.S. The political ramifications of this transport breakthrough also extend to global energy policies and climate agreements. The unveiling of this next-generation transport system is not just a technological leap, it is a defining moment in global history that will reshape economies, national security strategies, and diplomatic relations for decades to come. As nations grapple with the implications of this breakthrough, they must decide whether to adapt, compete, or risk falling behind in a rapidly evolving world. For the United States and other global powers, this development serves as a wake-up call, highlighting the urgency of investing in innovation, infrastructure, and strategic partnerships. The future will be determined by those who can harness this technology, navigate its challenges, and use it to shape a new era of global leadership. One thing is certain: the world is entering an age where speed, efficiency, and connectivity will dictate the balance of power. The choices made today will determine who leads the future of transportation, trade, and military strategy. The race has begun. Who will rise to meet the challenge?